Let's take a look at question number 21 in the exercise set 5.2. In this, we are given that Ian is looking at the top of a sand dune, and the angle of elevation to the top is 20 degrees, and as he moves closer to the sand dune, about 800 feet closer, the angle of elevation becomes larger by 15. So it's 15 more than what it was earlier. So it was 20 before, 15 more means plus 15 equals 35 degrees. What are we looking for in this question? We are looking for the height of the sand dune. To find that, if we drop a perpendicular from the top of the sand dune to the horizontal, we get a right triangle, and the height of this triangle will be the height of the sand dune. So if we redraw this triangle again, this is right height of the sand dune, two locations where Ian was, and we know the two angles are 20 degrees and 35 degrees. We want to find the height. Let's label that as h. What else do we know about this? We know that this distance is 800 feet. We do not know what is the distance between these 2 points. So let's label it as x. Now here, to make things easier, it would be best if we label these triangles. You can label it as you wish. I'm just gonna label it simple A, B, C, D. So A, B, C, D, and both triangles are right angled at angle B. So let's take a look at the bigger triangle first. So in triangle ABD, because we are not involving hypotenuse at all, the only trigonometric ratio that we can use, or we should be using, is the tan of an angle. So tan of 20 degrees will be opposite over adjacent. So tan 20, and opposite is h, and the adjacent side is BD, which is x plus 800. Now let's cross multiply to find what will be the value of h. So I put tan 20 over 1. You don't have to do it if you're comfortable without doing it. I just put it to show you that you can. This is how cross multiplication is working. So 1 times h is just h. So x plus 800 tan 20 equals 1 times h. And then we can distribute the tan 20 inside the bracket, so we get x tan 20, 800 tan 20 equals h. So let's leave this equation here for a moment, and let's look at the smaller triangle ABC, in which again, if we use tan of 35 degrees, we have opposite over adjacent. Again, I'm going to cross multiply to find what's the value of x. So x tan 35 equals h. So here, let's isolate x first. It's h tan 35 degrees. H divided by tan 35 degrees. Now this value of x can be substituted in this equation because we are only interested in finding h. So first we want to get rid of x. So in place of x, let's put the value of x, which is h divided by tan 35, into tan 20 plus 800 tan 20 equals h. So I think the easiest thing to do is to put in the calculator and find the value of tan 20 divided by tan 35. Let me see what we get. So tan 20 divided by tan 35 is 0.5198. Let's put that in. 0.5198 h plus 800 tan 20, so 800 times tan 20 is 291.1762 equals h. So from solving for equations, you remember you have to bring the terms containing h together. So let's move this one over there. Moving means we are subtracting 0.5198h from both sides. So what do we get? We get 291.1762h minus 0.5198h. It's like having, if we factor out the h, we are left with 1 minus 0.5198, and you can say you're collecting like terms. You can use whatever terminology you want to use, but really what we want to do is subtract 0.5198 from 1, which gives us 0.4802h. And from here, if we want to find the value of h, that means we have to divide both sides by the coefficient of h, which will be 0.4802. This will cancel out, giving us 1h. And then if I put that in the calculator to divide 291.172 by 0.4802, I get 606.4 feet almost, so which is almost equal to 606 feet. So that's how high the sand dune is.